Okay, let's take a look at, we're looking at test, this is test 14, our spring test 14 study guide. Number one, Number one says simplify the difference. Notice there's a minus in the middle. So you're doing the opposite of all the signs you see in the second one. You're still putting it in standard form, which means you're doing the highest degree first, which in this case is w squared. So 2w squared minus 4w squared. 2 minus 4 is negative 2w squared. Then go to w to the first power. Negative 4w, again, minus 2w is negative 6w. And then finally, at your constant terms, negative 8 minus a negative. Remember, minus a negative tells you to add it. So negative 8 plus 2 in this case is negative 6. There's your trinomial you make out. Number 2 and number 3 are really similar problems. Negative 1 is equal to the square root of j minus 2. You work your order of operations backwards, meaning you undo minus 2 first in this case by adding 2. If you add it there, add it here. Negative 1 plus 2 is positive 1 equals the square root of j. Remember, in order to undo the square root of something, you got to square it. You square the right side, square the left side. 1 squared, it doesn't matter how many times you multiply 1 by itself, it's still going to be 1. This is going to get canceled out, so you got j's value at 1. The difference between 2 and 3 is that for number 3, plus 2 is underneath the radical in this case, so you can't subtract 2 to undo it right away. You have to undo the radical by squaring it. If you square there, square here. Now it cancels out and gives you j plus 2. 8 squared is 64. Undo plus 2 by subtracting it on both sides. J is equal to 62. Number 4 says simplify the square root of 175. It's not a perfect square. You're looking for a perfect square that goes into it. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, those numbers. 25, or think of a quarter going into $1.75. It goes into it 7 times. Square root of 25, what times itself is 25? 5 times the square root of 7, simplified. Number 5, this one, you can't do as much on this problem as I would like you to just because of the number that pops up, but you undo your order of operations backwards. Remember, you undo addition and subtraction, multiplication and division, exponents and radicals. Nothing to addition and subtraction. There's multiplication and division. 2 times x squared. Undo that by dividing by 2 on both sides. Cancels out, leaves you with x squared equals 141. In order to undo squaring something, just like a minute ago you're doing the inverse, you just take the square root. Do it here as well. There is no perfect square that goes into 141, unfortunately, so this is the simplified answer. When you're raising a power to a power, 3g squared to the third, this is when you give the third to both of them. Notice it's a monomial. It's not a binomial like the ones we've been looking at lately. 3 squared, g squared to the third means g to the 2 times 3. 3, it's supposed to say 3 to the third. It's 3 times 3 times 3, which is 27. G to the 2 times 3, g to the 6th power. G to the 4th divided by g to the 10th means this is division now. G to the 4 minus 10, which is g to the negative 6. You can't leave it as a negative exponent, so make it ride the elevator. It's over 1. When it goes down, 1 stays on top. It becomes 1 over g to the positive 6. 4 to the 10th plus 2 to the 10th, they have the same radical 10, so add 4 and 2 to get 6. I said to the 10th a second ago. I mean 6 times the square root of 10. Number 9, we have 2 times the square root of 7 plus 5 times the square root of 12. We don't have the same square root like we did in number 8. So we have to take a perfect square out of 112. Remember, your perfect squares are 4, 9, 16, 25, those numbers. The square root of 16 goes into it times the square root of 7. Don't forget everything else, though. 2 times the square root of 7 plus 5 times the square root of 16. We know the square root of 16 is a perfect one. What times itself is 16 is the number 4. So you have 5 times 4 times the square root of 7 plus 2 times the square root of 7. So when you multiply 5 and 4, you get 20 square root of 7 plus 2 square root of 7. Now you have the same radical, the square root of 7. So you simply add 2 and 22 and 20, and you get 22 times the square root of 7 for number 9. Then we're foiling for number 10 and 11. First, 2x times 3x. 2 times 3 is 6. X times x is x squared. Outer, 2x times 2. 2 times 2 is plus 4x. Inner, 5 times 3x. 5 times 3 is 15x. And then L is for last. 5 times 2 is plus 10. Combine your like terms. You have 6x squared. There's nothing you can combine x squared with. This plus 10, there's nothing you can combine that. However, we do have 2x to the first powers. 4 and 15 is 19x to the first power. 6x squared plus 19x plus 10. We'll do the same thing for number 11. We're foiling it. First terms, 3x times 2x is 6x squared. 3x times 4 is plus 12x. 4 times 2x is plus 8x. 4 times 4 is plus 16. First, outer, inner, last. 6x squared. 12x and 8x is plus 20x plus 16. First, outer, inner, last. Foil. Number 12 said to simplify using the distributive property. Again, it almost acts just like FOIL. Take the first term in the binomial 5h and multiply it by the whole binomial that's second, 4h plus 3. Then take plus 3 and multiply it by the second binomial again, 4h plus 3. So distribute 5h times 4h is 20. H plus h, h to the 1 plus 1 is h squared. 5h times 3 is plus 15h. 3 times 4h is plus 12h. And 3 times 3 is plus 9. You're going to do the same thing. 20h squared plus 9. Those are the two that don't have any that you can add to, but we can combine 15h and 12h to get positive 27h. Then you say solve using the zero property. Well, we have 2x minus 8 times 8x plus 11. One of these has got to be equal to 0 since it says it's equal to 0. So you simply set them both equal to 0. 2x minus 8 equals 0, and 8x plus 11 equals 0. So undo minus 8 by adding it first. So you have 2x equals 0. Equals 8 plus 0, which is 8. Then divide by 2 to cancel out multiply. And x equals 4 is one of your answers. The other one, you subtract 11. So you have 8x equals negative 11. You divide by 8, and you have x equals negative 11 over 8. You're going to do the same thing with number 14. X minus 11 equals 10. Equals 0. And 6x minus 3 equals 0. Get rid of minus 11. By adding it, x equals positive 11. Get rid of minus 3 by adding it. 6x equals positive 3. Get rid of 6 times something by dividing by 6. X equals 3 divided by 6. The number 3 goes into both of them and goes into itself once, and then the 6 twice, 1/2. The same thing for both 15 and 16. Either 3 times n equals 0 or 2n minus 1 equals 0. So get rid of 3 times something by dividing. 0 divided by anything is 0. Undo minus 1 by adding it. 2n equals 1. Undo 2 times something by dividing it. N equals 1/2. So 0 or 1/2. Same thing with number 16. Either negative 9 times n equals 0 or 2n minus 4 equals 0. Divide by negative 9. Again, 0 divided by anything is 0. Undo minus 4 by adding it. 2n equals positive 4. Undo 2 times something by dividing by 2. N equals 0 or n equals 2. And then you're doing the same thing for number 17. You're just doing 5x plus 5 equals 0 or 2x, right in now, 2x minus 2 equals 0. Undo plus 5 by subtracting it. X equals 5x, equals negative 5. Undo 5 times something by dividing by 5. Negative, keep one right in, negative 5 divided by positive 5 is negative 1. Undo minus 2 by adding it. 2x equals 2. Undo 2 times something by dividing by 2. X equals 1. Negative 1 or positive 1. We're solving these by factoring. So now you're going to factor them, and then you're going to set both of the things equal to 0. So we have, it's in standard form already, so z, you treat it just like it says x. All of our examples have been using x. Your factors of c, remember this is ax squared plus bx plus c. Your factors of 4, 1 times 4 and 2 times 2. The only ones that get you to b's value 3 is 1 and 4. Remember, this one right here tells you that they're going to be different signs. Since they're different, this one tells you the bigger number is positive. 4 is bigger than 1, so it's positive. That means z is minus 1, negative 1 equals 0. So now you have z minus 1. You set them up as z minus 1 equals 0 and z plus 4 equals 0. Get rid of minus 1 by adding it to both sides. Z is positive 1. Get rid of plus 4 by subtracting it on both sides. Z is negative 4. All you're doing is factoring these right here. W times W is W squared. Your factors of 77, that gets you to 18, or 7 times 11. This tells you both signs are the same. This tells you they both plus. So plus 7 plus 11. Two binomials again, D times D. Your factors of 36, if you need to list them, are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Which pair gets you to B's value 13? The only one that gets you to the number 13, or the only set, I should say, that gets you to the number 13 are 4 and 9. So this tells you they're the same sign. This tells you they're both plus. So plus 4, plus 9. Same thing for this one. Two sets of parentheses, x times x is x squared. Your factors of 42 that gets you to B's value, which is 1 right here, is 6 and 7. This tells you that signs are opposite of each other. One's going to be plus, one's going to be minus. This sign right here tells you the bigger number is minus. So 7 is bigger, it's going to be minus, 6 is plus. Two sets of parentheses, x times x. Again, what factors of C, what factors of 48, get you to B's value 14. 8 and 6 are the numbers you're going to use. This tells you the numbers, the signs are the same. This tells you what they both are, plus 8, plus 6. Then number 23, the same thing. You're going to set two sets of parentheses, x times x. Your factors of 10, the factors of C that are going to get you to B are 5 times 2. Same sign, both of them negative. Minus 5, minus 2. X times x. Your factors of C, 63, that gets you to B's value 2, are 9 and 7. Opposite signs. Biggest one's positive. 9 is plus. Opposite signs, 7 is negative.